So hello again, everyone. In this video, we are going to solve recurrence relations. So when we solve recurrence relations, it usually involves finding a closed form solution to the sequence of numbers defined by the recurrence relation. So we have a geometric progression example here, starting from 3, followed by 6, 12, 24, 48, and so on. So what pattern can you see, or how can we generate the sequence? Okay. So we can generate the sequence using a recurrence relation. So when we say recurrence relation, so um, let's say we have a sub n, it is defined by the previous the term a sub n minus 1. Okay, so what pattern can you see here? So we see that the next number, let's say 3, followed by 6. So we simply had to multiply uh, 2 to this number 3 in order for us to obtain the 6. And in order for us to get the 12, we simply have to multiply the 6 times 2 by 2, and so we can obtain 12. And then obtaining 24, we simply have to multiply this by this the 12 by 2 also. So essentially what we do here is, in order for us to get the next term a sub n, then we simply have to multiply 2 to the previous term a sub n minus 1. So if we have this 3 and 6, so this 3 will be the a sub n minus 1, and 6 will be a sub n. So in a more formal or in a more specific term, so this 3 is our a sub 1, and 6 is our a sub 2. Okay, so let us try to validate whether this recurrent solution is correct. So we have the a sub 0 here, which is equal to 3. Okay, so in order for us to get a sub 1, so that would be 2. Sorry, this would be a sub 0, and this should be a sub 1. Okay, so 2 times a sub 0. Okay, and we know that a sub 0 is equal to 3. So we simply have to substitute here, and a sub 1 is then equal to 6. So now, in order for us to get a sub 2, so we need to compute for 2 times a sub 1. Okay, and we know that a sub 1 is equal to 6, so that is 2 times 6 equals 10 will be 12. Okay, so now our problem here is, let's say we wanted to solve for, let's say, a sub 500. Okay, so that means that we have to compute for a sub 400, a sub 399, and so on and so forth until a sub 0. Okay, that will take us a lot of time. So what we can do is to find a closed form solution that can also generate a sequence, or a closed form solution to the sequence of number that is defined by the recurrence relation. So here's an example of a closed form solution. So this geometric example can also be computed using this solution, which is a sub n equals 3 times 2 raised to n. So in this case, we have 3 a sub 0. So 3 times 2 raised to 0, that will give us a 3. A sub 1, that will give us 3 times 2 raised to 1, that will give us a 6. And a sub 2, that will give us 3 times 2 raised to 2, which is equal to 4 times 3 and 12, and so on and so forth. So if you wanted to compute for, let's say, a sub 500, so that would give us 3 times 2 raised to 500. Okay, and then we can already compute for the value in the 500 position of the sequence. Okay, so I hope you have already understood recurrence relation and solving recurrence relation. And as I mentioned, when we solve a recurrent solution, so we are essentially finding for the closed form na solution. Okay, so in the next slides, I will show you how we can solve recurrency really, or the step-by-step solutions in finding the closed form solution.